So as part of my reinforced concrete class, I have the students apply what they learn doing a small design project, and this is the introduction to that project. Now, for those of you not from my class, this project is not intended to be a senior capstone project, but just a small application of design development. And so what I'm going to do here in the next few videos is go over the process of structural design and then put this little project in its context and then describe the project. And then we'll get into the actual design aspects. So if you're a student from my class, I guess you can skip all the videos, although I wouldn't recommend it, that say introduction in it, like this one. So before I go into a description of the project, I thought I would talk about structural systems and the design process for the structural engineer. And so typically when you do the structural engineering for a building project, there are three structural systems that you'll design: the vertical load resisting system, the lateral load resisting system, and the foundation system. And I'll go through a quick definition of all three of these. So the vertical load system, which is what we will do in this class, my reinforced or structural concrete class, we're going to do this. The vertical load system resists gravity loads, dead, live, snow, roof, etc. Okay, so it's gravity loads only. And the components typically are a slab, beam, girder, and column, which is exactly what we'll be designing, well, parts of the building that we'll be designing in our class. It also would include, in a real job, maybe bearing walls, connections, roof and floor. We will be doing the roof and floor slabs, but we won't really be doing these things here in our class. We have limited time, and especially the students, they don't have time to go into a full design, and they have a capstone class where they do all these things. So this is just to apply the structural concrete concepts they're learning in my class. We will not be doing this in our project, but typically in our capstone project, you will. You would design the lateral load system that would handle wind and earthquake loads, and maybe fluid and soil loads. And the things you would design are the diaphragms. Typically, even in our capstone class, we skip over designing the collectors. But we certainly then design shear walls or braced frames, depending if it's a concrete or steel building. And we also have our students design moment frames. So typically, so the students can get both. We'll do braced frames in one direction and moment frames in the other direction for a steel building. Although we will not be designing a lateral system, and certainly not moment frames for this concrete class, I do want to take a little aside here and talk about some history at the University of Wyoming and reinforced concrete moment frames. So what I'm going to do is I'm going to turn on my camera because I do all these things on just one take edits, and I don't really post-process this, so this is just going to be what it is. So I'm going to try to turn on my camera, if I can find it. There it is. And so here you go. Let me take a picture of this. Oh, it won't take a picture. Anyway, this man here. Okay, so let me turn back to what we're doing. So that man in that picture is Wayman Wing. And that building in that picture was the first moment resisting frame designed in the United States. And Mr. Wing is a University of Wyoming graduate. So anyway, we won't be doing things like that, but just some history connected to the University of Wyoming. Okay, well, let me just double check that I'm actually recording all this. Just 1 second. Let me see. Yes, I am recording. Okay, back to what we were doing. And so you'll do the gravity system, the lateral system, and also a foundation system. And this will take the loads from the structure to the soil, and also resist the loads from the soil to the structure in terms of retaining walls, like in a basement. We won't be doing that, but we will be doing this. And typically, you need to design the footings for both vertical and lateral loads. But since we are not doing the lateral loads, we are just going to do this. And you would have foundation wall, basement walls, grade beams. We are only going to do this spread footings in our project. We're not doing any of the other foundation elements. So a lot of these pieces are double duty. They are part of the lateral load system and the gravity load system. So for example, the floor or the roof deck, they resist the gravity system as floors and as slabs, and then they help in the lateral system as diaphragms. A bearing wall that's holding gravity loads could also act as a shear wall. And braced frames or shear walls, moment frames that are part of the lateral system also can carry vertical loads. And so basically, this is an important one. Vertical systems can carry lateral loads. The building doesn't know what you've designed the different parts for. And this can cause trouble. We won't be talking about lateral systems, but often in a building, in an earthquake, gravity component will undergo lateral loads and suffer damage. We can talk more about that later. You need to understand the system load path. You don't really need calculations, and you need to follow the load all the way to the ground and understand each component's purpose. This type of understanding is crucial in the detailing and in the design of the building. And if you understand the load path, it'll help you understand the connection details. And you also conversely need to understand the details of how things are built to understand if they will be able to perform in the load path. So next, I want to talk about project design phases, and this is typically what we do in the US. So first of all, why would you need to have design phases? So this is phases in just the engineering design. You need phases so you can coordinate the different disciplines, the architectural, structural, mechanical, and electrical. And in our architectural engineering major, you learn about this because you do cover structural aspects of a building as well as mechanical and electrical aspects, and certainly the architectural aspects. Design phases also introduce intermediate viewpoints, so milestones where you can stop and say, are we all on the same page, literally? And then finally, you need design phases so you can track costs, and particularly so you can bill. You can bill your client. You say, oh, we finished schematic design, the 15%, so you maybe get 15% of your fee at that point. The design phases, we're going to break up into 3 parts, and 2 of them fall under preliminary design and 1 is under final design. We'll talk about schematic design, design development, often abbreviated just DD, and construction documents. This course in structural concrete will cover only this. We won't be doing the schematic design, and unfortunately, we will not be producing construction documents. We have an entire course that's supposedly was originally designed to cover specifically construction documents, our CE design class, CE 4010. But that's morphed a little bit, but we understand that, at least in our program, this gets not enough attention, this step 3 here. And we try to address that with CE 4010. You have lots of classes in here. You have concrete design, steel design, timber design, masonry design. Almost no classes in here. And we thought we had one class in there, but it's coming along. Anyway, this class will be only design development. So when we say design project, it's not an entire project, it's just a design development. Since we're not covering the schematic design, in the next lecture or video, I'll cover that a little bit just to give you an overview of what we're not doing.